This video is for the activities and exercises of Wednesday. A reminder, the data collection activities of the day are to do the collaborative wall, and the question of Wednesday is what problems could patterns help serve the real world? And remember that patterns here is a proxy for algorithms. Throughout the day, a reminder, especially to the TAs, of capturing presentations done by the students or anything that would be worthy of capturing. If they're doing a competition, if there's a lot of fun being had, these are good opportunities to capture video and to take pictures. The first activity that you will do in the day, as every day, is to create your teams. Do this by hand. Try to balance your team so that you don't have too strong a team or too weak a team. And so with that, let's go ahead and move into the activities of the day. The first one is an activity on encoding information. And this will be another one where you will play the role of the magician. And the trick in this activity is how you present the information so that you don't give away what you're doing. So you'll start off by creating a grid, a 5x5, and you can just shade in each of the cells at random. You can take suggestions from the audience. And then after you do that, you say, well, let's make it even harder, add a column and a row, and just seemingly at random, now you fill in or tick off some of those cells. Now at that point, you get to go outside the class, and quietly the class will change one cell, and then you'll get to come back into the classroom and concentrate and look at the picture, and you'll be able to guess your change. And so the question is, how do you do it? And you simply, what you're doing, without telling anyone, is that when you add your column and your row, you're really making them even, so that when a change is made, you will be able to detect it because now you have an odd summation. And so that's the trick. You can then ask the students to try to replicate it in their own groups, and you can have a volunteer or two go out of the classroom, then come back in and quiz them. And this is, again, challenging because you have to sort of do your summations on the fly, and there's some pressure because everybody's watching. And so this is another one of those activities that was a lot of fun. And so that's this question here of demonstrating. When it comes to encoding information, another activity that you can do is ISBN verification. This is a number that most of us have seen. Here is how you do that verification. I opted not to do it last year because it seemed a little bit too involved and not as fun. Next, you're going to work on searching. You can make the announcement that the next day will be sorting, but that this day will be searching. And the first exercise is to grab 15 index cards, write numbers on them 1 through 15, shuffle the cards, ask 15 students to come up to the front of the class. You then give them, each of them, an index card which they'd hold, not showing it to the class. And then you ask the teams as you go around the class to make a guess. They're looking for a number that we have selected, but the numbers are shuffled within the people in the front, and so it will be hard for them to come up with a strategy. So once they're done, you can do a couple of rounds of this. Once they're done, you can move on to the next activity, which would be to then order the numbers 1 through 15, distribute them throughout the students, and you can announce to the class that you've made a change. And you can ask them to try to come up with a strategy as they ask for questions. Now, if they spot what you've done, they should be able to zoom in to a binary search, assuming they're thinking that way. And so this is a way for you to approach some of these topics. Now, last year this was a activity that was of medium success, not great success. It was a bit cumbersome, but sorting, by the way, had that same challenge as I mentioned during a workshop as well. Now the next one, which was of great interest, was what is the minimum number of guesses to find a number between 1 and x? And we gave him here 1, 100, and 1,000. And this is one of those that leads to a lot of discussion and a lot of collaboration within the groups. And then you can ask them, once they come up with the minimum number, is to what strategy are they using. And here we're carefully hinting at exponential or at growth of complexity and at a problem that seemingly is quite difficult that has some interesting properties. You can announce that in the next day there are going to be strategies for sorting, which obviously have an impact on how you search a space. This is a good opportunity always also as well to point out some of the properties of what has taken place in the exercises. And you can quiz teams, you can get some discussion going around these questions and these properties of the exercises that you have done. The next topic of the morning is one that was a great deal of fun, and a lot had to do with how the exercises were structured. Cyphers basics were covered, and then teams were asked to go head-to-head in classrooms around, on the whiteboards in the classroom around the walls. And so all teams were going up against each other, and it was, they were being supported by, by the other team members, and it was a great deal of fun. So we start off with the most basic thing that you can do to encode information, and that would be here a hash function. This would never really be used in a crypto security context, but it is important to give them some time to become comfortable with the concepts. For many of them, and for just about all of them, this is the very first time they've seen them, and so it is good to start out slow. So we start off with the most basic. You can see here the example. We simply give the alphabetical numerical order to the value of the letter, and we come up with a number. And so you can see here how we encoded a number of these words, and we asked them to then try to solve them or to try to create some. And so this is a good opportunity, again, for activities. They can run in parallel. They can consider the use of these as they exchange notes and some of those fun type of considerations. We also look at ROT 13, same approach, and you can see here some samples, and Rails Cyphers as well. This is one of those that has a little bit more hands-on components to it, and it's a little bit weirder, and it has a key that you need to consider. And so this is one that I think was one of the most successful of the exercises that we did. You can see here some of the encodings. The last activity of the day was binary decision trees, hooking on to the activities of the morning, and how would you leverage those concepts to structured information. You can emphasize the concept of speed and just navigating how that is a really good fit for a lot of online applications like shopping and really many commercial applications that structure information. Those activities will put you at midday when you have your lunch, and then coming back that afternoon, we're going to cover a number of topics, which is timers, coordinate systems, some of the ideas surrounding computational geometry, and simulation is the big one to emphasize, and that is moving in time, moving in space, and refreshing a visual displays or graphic system. In this one, I'm going to be using the console, so go ahead and open that up to follow along. I'm going to be doing that myself here. And let me make my font. Actually, I'll keep it that size. The very first thing to look at is your hello world timers function. I'm going to go ahead and pull that in. I put it into a file as well, as you can see here. Where is the timer? Let me see, get back my mouse. Here is the timer. And I'm going to go ahead, and it's simply the code that we have there on the slide. I'm going to go ahead and pull in that timer to the page, and as you can see there, we're getting numbers being written to the console. And let's go ahead and take a look at the code to see what's going on. You can see there that I have a counter that is maintaining state. Then I have set interval, which is a function within JavaScript that calls back a function at a certain time interval. And the time interval is set in milliseconds. So you can see there that on every call back to this function, on every execution, on every interval, it is executing the following code or the following function. You can see there that the counter is increased by 1, and then that value simply being written to the console. And so that is simply running and executing at every half a second. So let's go ahead and go back. You can see there that it'll simply keep on running. So timers is something obviously that are part of many languages, and this is something we want to emphasize. And in this case here, we are going to use it to do animations and simulation. So our first exercise, once you demonstrate what timers are, you can ask them to do a timer themselves, is to horizontally move a ball using a timer. And you can see here the code for that. This is something that, again, requires some getting used to if you haven't seen this before. The girls struggle with this concept. All of them came around and eventually got it. But for some of them, it took quite some doing because it is a number of abstractions that you're working with, and we're building on what we have been doing all week. So that is manipulating a ball on the screen. As you can see here, the variables that I am creating is one for velocity, and this is the rate of change that I'm using. The other one is a position, which is a global, and where I am keeping track of where the ball is. I then get a handle on the ball to use it programmatically, and then I am using a timer, and as you can see, the code in itself is quite simple, but there's a lot of concepts built into it, right? So on every callback of the interval, you can see there that I am updating the position by increasing it with the rate of change, and then I am setting what would be the X position, which is ball.style.left, and adding pixels, and this has to do with how the dimensions need to be set in the browser. So again, it's a little quirky. There's a lot of concepts, and so this is why it takes some getting used to simply move the ball across the screen. And so let me go ahead and demonstrate that, and I'm going to go ahead and show you the code, and that is here move ball simple, and I'm going to put it on the screen, and you can see there that simply moves the ball across the screen. And so let me emphasize again that this takes some getting used to, and that you should expect your students to move slowly through this, and that also you'll get a lot of variation. Some of them will do it faster, much faster than others. The next thing that we want to do, and this is again another concept from computational geometry, is we want to detect a certain edge that we're going to call for. And in this case, it's simply here 200 pixels. And you can see there that I'm considering a couple of cases because we're only working in one dimension. Once you go off of the end to the right, and once you go off the end to the left, you want to reverse those velocities and change the trajectory of the ball. And I'm going to go ahead and show you that here, which is, oops, let me go ahead and bring back the browser. And I'm going to move the file. And as you can see there, we have the same movement. However, now the ball, once it reaches the coordinate, no, I'm sorry, that was not the right file. It is this one. Once it reaches that pixel limit, is going to come back and then is going to do the same on the other end. This is one of those that even in university, whenever you give students this for the very first time, it is something that requires some thinking. So give them the opportunity to think through that, give them the opportunity to come up with it on their own, hint along, but this will take them some time. The next one is, this took the whole 2 hours last summer, but for those that went through it pretty fast, you can ask them to do the same thing in 2 dimensions, and I believe I called it bonus. So let me go back to my browser and load this here, and just simply to show you. And it is the same thing, except of course now it is doing edge detection in 2 coordinates, and that requires an additional case to be considered and more things to be tracked. I'll leave the code for you to investigate, and this time I have a bunch of more bonus questions. And you can really get into this problem, and it can really teach you a lot. So you can see here the type of considerations that I have, which is change speed on bounce, change color on bounce, change color depending on the direction of the X that you're moving in, change color depending on the vertical dimension that you're in, change size on the bounce. There's a number of things that you can do, and let me go ahead and show you a few of these here just for fun. So I'm going to go ahead and drag some of these in, and so let me go ahead and show change of size. This is moving across the screen, and when it bounces back, you can see there that it's become small, and then when it bounces back again, you can see it's become big. This next one is going to be change of speed. It goes in one speed to the right and another speed to the left, and you can see there that you can get pretty ambitious. I have one here that is, I called it hard because it is creating a number of these. These are all moving at different speeds. And so you can see there that you could have a lot of fun, and that's the objective for this exercise. So let's go ahead and go back to the code, to the slides. And that'll put you at the end of the day, which is project time. There is already a milestones document there for them to complete on that day, and that'll put you at the end of the day. Now here come the data capture activities at the end of the day. Instructors submit your reflections, same thing for TAs. TAs remind the students to do their 1-minute video that they need to submit at the end of every day. And so with that, that is the end of this video.